Hi class, today we're going over lesson 7.6, finding the probability of compound events. Alright, so the probability of a compound event can be represented by a ratio of the number of favorable outcomes to the total number of possible or equally likely outcomes. You can use an organized list, a table, or a tree diagram to determine the number of favorable outcomes and total number of possible outcomes. So this is very similar with our theoretical probability that we worked with in the past. This is just simply applying it to compound events now. Alright, so let's start with an example. Imagine you have a spinner with 5 possible outcomes and you are also flipping a coin. Make a table to show all the possible outcomes, then say how likely it is that the coin will land heads up and the pointer lands on a 1, a 2, or a 4. Alright, let's start by making our table here. So when we have heads and a 1s, our combination would be 1 head and 1 1. We'll fill in the rest of this table here, right? So we have a tails and a 1, tails 2, tails 3, tails 4, tails 5. So are our possible outcomes here. So how many possible outcomes do we have? Well, 10, right? We have 5 from our spinner. We have 2 possible outcomes from our coin. You multiply those together and you will get 10. So that's going to be our denominator right here, our total number of outcomes. Now we want to find out when the coin lands head up and the pointer lands on a 1, a 2, or a 4. So for starters, we only want to look at heads, right? So we're going to be looking at this first column. So we have a head 1, a head 2, and a head 4. So that's 3 possible outcomes, right? So we have a 3 in 10 chance of us flipping a coin and spinning a spinner and landing a heads 1, a heads 2, or a heads 4. Alright, so each week a clothing store gives away a t-shirt. The shirts vary by sleeve type, long sleeve, short sleeve, or no sleeve, and color, gray, blue, or pink. And it wants us to draw a tree diagram to represent the sample space and find the probability that the free t-shirt will either have long or short sleeves and be either pink or blue. Alright, so first we're going to start with long. So what are our 3 options for long? Well, we could be gray, blue, or pink. Now for a short sleeve, we have those same 3 options: gray, blue, or pink. And finally, for a no sleeve, we have gray, blue, and pink again. And we want to find out the probability that the free t-shirt will have either long or short sleeves and be either pink or blue. Alright, so long and short sleeves are our 2 on the left, so we can get rid of no sleeves, right? We're not going to have a no sleeve option here, so it leaves us down to 6. Alright, so we want to find out if it's long or short sleeves. We have these 6 here, and then pink or blue. So we'll highlight pink and blue on both of these, and we'll get our options. So we're getting rid of gray here. All right, so let's find our probability. Well, how many total outcomes did we have? Well, we had 3 of each, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So our denominator, or our total number of outcomes, is going to be 9. Now, how many of these were favorable? Well, it was the blue and the pink of the long and the blue and the pink of the short. So that was 4 favorable outcomes. Or we have a 4 in 9 chance of having a long or short sleeve shirt with either pink or blue. Okay, so today we found the probability of compound events. To do this, we modeled the possible outcomes using tables, listed examples, and tree diagrams. We're going to have some more examples in class tomorrow.